Good morning and welcome to Lesson 1 of Unit 4. Unit 4 is Forces and Motion. Right now I'm on page 172, looking at the essential question, how is an object's motion described? By the end of this lesson, you should be able to describe the motion of an object in terms of reference points, direction, speed, velocity, and acceleration. So let's get started. Alright, I'm on page 174. How is motion described? Alright, what is your current position? Well, you need to understand what position means. Position is the location of an object. Okay? If you decide to stand up and move around, you will move from one position to a different position. Motion is an object's change in position relative to a reference point. Okay, so whenever your position changes, you are in motion. Well, what is a reference point? So I'm at the red subheading. A reference point is a place or object to which another location is compared. Okay. When describing position or motion, a reference point is used to make the description clear. Okay. A lot of times you don't say what reference point you're referring to because most commonly we assume that we're talking about our reference point would be like the surface of the earth. So I'm walking along the surface of the earth towards the door, or this or that. Okay. You could describe a position as 3 seats to the right of the door, 2 meters to the right of the door, or something like that. But if you're talking about calculating speed or velocity or acceleration, as we'll do later in the lesson, usually your reference point is just the surface of the earth. Okay, and I will use the term frame of reference probably more than I will reference point, but they both mean the same thing. Okay, it just means the object that the motion is being compared to. All right, look at page 175. Distance and displacement. One way to measure the change in position of an object is to measure the distance traveled. If you ride your bike 2 miles to school every day, you ride a total distance of 4 miles because you ride 2 miles to the school, 2 miles home. This distance is not necessarily traveled in a straight line. Another way to describe motion is to measure its displacement. Whenever an object changes position, it is displaced by a certain distance. Displacement is the straight line distance between a starting point and an ending point. Okay, the displacement from one place to another is the same no matter what route you travel to get there. This means that distance can be very different from displacement. Okay, if you look at the illustration, the orange line would be like if you were able to go straight from home to the school parking lot, you would probably follow that orange line. Okay, if you've ever heard the term as the crow flies, which means the crows they don't have to walk around certain things, they can just fly straight from one place to another. Okay, so displacement would be the straight line distance from your home to the school. You, however, might take the pink path through the park, winding around. You can see that that's a much longer distance to get to the same location. You might go in a car and go around the streets to get to the school. But just understand that distance and displacement are not the same thing. Another great example is think of NASCAR races, something like that. You have a car going around and around and around on an oval track, and it may drive a distance of 500 miles. But if it starts and finishes at the starting line, its displacement is 0 because it finishes the race in the same place that it started because all it's doing is doing laps. So that car's traveled 500 miles. The odometer says 500 miles have been traveled on it, but it hasn't gone anywhere because it ended up in the same place that it started. So distance and displacement are definitely not the same thing. Okay. All right, now I'm on page 176. How is speed described? When you change position, you experience motion. Well, speed is the measure of how quickly distance changes with time. And the standard unit of measurement for speed is meters per second. And that's actually the answer to number 9. What is the standard unit of speed in the SI system? Meters per second, often abbreviated as m/s. Okay, so speed, I'm on the red subheading. Speed is how fast an object is moving. To find speed, divide the distance by the time spent moving. How can you use speed to tell how fast an object is moving? Well, suppose a car is moving at 26 meters per second. The speed 26 meters per second means that the car travels the length of 26 meters sticks during every second. If the speed doesn't change, the car will travel 260 meters in 10 seconds. Average speed is the change in distance over the change in time. I'm on the next red heading. In most cases, the speed of an object is not constant. When you ride a bicycle, sometimes your speed increases, sometimes your speed decreases. Average speed describes motion over a period of time. The average speed of a moving object is the total distance traveled divided by the total time traveled. Okay? Average speed equals total distance divided by total time. When you find average speed, you're not really taking into account the little changes in speed along the way. You're just looking at how far did you go, how long did it take you. That's average speed. On number 10, it says use the formula that they just gave you to calculate the average speed for an 880 kilometer trip that takes 9 hours. Well, the average speed is going to be the total distance traveled divided by the total time. And that's going to be 880 kilometers divided by 9 hours. And if you do that math, the average speed is going to be 97.8 kilometers per hour. Are you going exactly 97.8 kilometers per hour at every moment in that trip? No. But on average, you're traveling 97.8 kilometers per hour. All right, let me show you what all I've got for these first several pages. All right, I am back on page 174. I have underlined the definition for position. I've underlined the definition for motion. And I've underlined the definition for reference point. I've also added a few things. I added down there, it says frame of reference means reference point. They're synonyms. They mean the same thing. Both mean the object that motion is being compared to. Means the object. I'll put a that in there. The object that motion is being compared to. The most common frame of reference is the Earth's surface, or something, directly attached to the Earth's surface that's not movable. Okay. On page 175, I underlined where it says one way to measure the change in position of an object is to measure the distance traveled. And then I also underlined the definition for displacement. Displacement is the straight line distance between a starting point and an end point. Please notice that I marked number 8 as omit, meaning you do not need to do that one. Normally those ones that are in those green think outside the book take a lot of time, and that's not something I want you to worry about. So you can mark out number 8 on page 175. On page 176, I have underlined the definition for speed. Speed is the measure of how quickly distance changes with time. I also underlined the sentence that said the standard unit of measurement for speed is meters per second. I have answered number 9 with you. What is the standard unit of speed in the SI system? It's meters per second, or we can abbreviate it as m/s. Under average speed is the change in distance over time. I underlined where it said, in most cases, the speed of an object is not constant. I also underlined the average speed of a moving object is the total distance traveled divided by the total time of travel. And I put a little thought bubble around the average speed formula, total distance divided by total time. Number 10, use the formula to calculate the average speed for an 880 kilometer trip that takes 9 hours. And you'll notice I put S with a little AVE, meaning speed. AVE means average. So I'm calculating average speed. I just abbreviated it. It doesn't say save, it says S average speed, Notice I put a triangle distance divided by triangle time. Well, instead of writing out the words change in science, a lot of times people just abbreviate change as a triangle. So change in distance divided by change in time, and you get 880 kilometers divided by 9 hours. The average speed is 97.8 kilometers per hour.